Now we'll take a look at IntelliSense. IntelliSense is a predictive typing tool that aids developers during the coding process by supplying a list of potential elements from the AOT. When the developer is typing, it'll prompt the user for known methods and possible choices that are available in the AOT in the system for Dynamics 365 for finance and operations. It helps ensure consistency and making sure that items are consistently used. It also helps maintain consistent spelling of elements. Let's take a look at using IntelliSense in Visual Studio. In this demonstration, I'm going to show you the basics and how IntelliSense works to aid you in your X++ code. So what we can go ahead and do is we can do a couple of things, and we'll just go ahead and open up a class within the AOT that has already been created. And I'm just going to go ahead and go to a class from our fleet management example in the system here. So I'm just going to go ahead and navigate to that. So we have FM rental scenarios. Let's go ahead and do FM rental details and see what we have there. So I'm just going to right click it and just open it in the designer. So here we can see that in the designer. And I'm going to right click and we want to view the code. So here we can see our class, which is declared up here, the FM rental details. And then we are declaring all of our different variables. So we have the string customer ID, and you'll notice when we do this, we'll say, maybe we want to add another one. Notice I type in ST and then R, and here we have string. So IntelliSense is basically kind of guessing what we're going to be typing. And so yes, I want to use the string. So I'll press enter and then continue on, and I might, use something, customer account, and then add a semicolon at the end of that. I'm just going to go ahead and delete this line of code since we really don't want to add it. We can scroll down here and see, once we start adding methods, so I'll add a line down below this as well, or above it, just to show you. So I can start typing in public, we'll do enter, and then, maybe we're making this, we can go ahead and start typing that in, and it will just basically kind of aid you in your development. And I can click enter, and then I can start typing in what I want here as well. And you'll also notice as you are developing, IntelliSense will also indent things for you as you go so that your code is nice and consistent and looks correct. Also, when we do our comments, the comments will automatically turn green. And you can see that this is a comment, and the compiler will know not to compile that line of code, obviously. And so we can see down here, we have a date here. We have other methods that are all throughout here. If we start typing in else if statement, it will also see that. So I'll start typing else, and then it will know, once we start clicking in if, and we can continue on with our coding. So IntelliSense is really helpful with your coding and development while you are coding for Dynamics 365 for finance and operations. Now let's take a look at data types. Data types are used to present different forms of data in the system. We'll now take a look at primitive data types, composite data types, and extended data types. The basic set of primitive data types in Dynamics 365 for finance and operations map to underlying data types that exist in the physical database. These primitive data types can be expanded to create extended data types, which are reusable data types having a specific definition. There are several different primitive data types that we can use. First is any type, which is a placeholder for any data type. Booleans can only contain the values of false and true. Dates contain the day, month, and year. Enums are an abbreviation for enumerated text or a set of literals. We also have a globally unique identifier. We also have an integer, which is a number without a decimal point. We also have reals, which is numbers with decimal points. We also have a string, which is a number of characters. Time of day, which contains the hours, minutes, and seconds, And then lastly, the UTC date time, which is the year, month, day, hour, minute, and second. Let's take a look at composite data types, which are those that contain other data type constructs. First is an array. This is a list of items with the same data type and same name, only the index will be different. Next is containers. A container is a dynamic list of items containing primitive data types and/or some composite data types. A class is a type definition that describes both variables and methods for instances of the class. And lastly, a table is defined in the database and can be handled as class definitions. Extended data types, or EDTs, are user-defined types based on the primitive data types, Boolean, integer, real, string, date, and so on. These data types have properties such as labels, help text, size, and display characteristics. In the AOT, the data dictionary, you can find the extended data types node, and it's also used to create EDTs. The range of an EDT is identical to that of the base type it is based on. There are several benefits of using extended data types. First, the code is easier to read because variables have a meaningful data type. So for example, name instead of string. Next, the properties you set for the EDT are used by all instances of that type, which reduces work and promotes consistency. And lastly, you can create hierarchies of EDTs, inheriting the properties that are appropriate from the parent and changing the other properties. Next, we will review key variable declaration techniques. It's important to declare variables in small scopes. This allows for easier readability, and it is within the block of code that you are using. You should also declare variables prior to using them in an executable statement. This is scoped closer to use. Additionally, the var keyword is available to infer the type. This is used for declaration of variables, and it must be clear for inferred type in initialization. And lastly, you should assign a value to a field in line with the declaration. This reduces code lines and improves readability of assignment. In the EDT code sample you see here, this is a declaration of a string using the extended data type. We are using the EDT DB vehicle type that we created earlier in the course. You can declare multiple variables of the same type by using a comma to separate the values. So you can see here we have DB vehicle type, and then we have DB vehicle type 1, and then a comma, vehicle type 2. You can also initialize a variable as part of the declaration using the equals operator as well. So here we have the vehicle type car equals car. In this demonstration, I'm going to show you the use of the var keyword. So here I have my DB Fleet Management project open in the Solution Explorer, and I'm just going to open up the class I was using that I had created before, and we're just going to set our variables. Maybe we'll set the values for those. So here I have my class and my public static void main method. I'm just going to go ahead and delete this info log that we created, and what we're going to do is we're going to set our variables for different things in the system here. So for instance, I'm going to type in var, and we can see IntelliSense knows that what we're going to be typing, and we're going to set our gallons used in this case, and let's set this variable to equal to 0. So I just put an equal 0, and I'll put a semicolon at the end of that line. And then let's set another variable, for instance, for the number of miles driven. So we're going to say var, and we're going to say miles driven. And I'm going to set this variable equal to 500, for instance. And then what we can go ahead and do is perform an arithmetic operation. So maybe we'll say, gallons used And here we have our variables that we created. So now that's showing in using IntelliSense, and we're going to say is equal to miles, and we'll go ahead and press enter, miles driven, and we're going to say divided by 25. I'll do a semicolon. And then basically what we want to do is display in an info log the amount of gallons used. So we're going to say info. And then what we want to do is we've declared our gallons and miles driven as an integer, but we want to display this in string format. And so we can do this by using this syntax, and we're going to say integer, which is int to string, and you can see that we can select that here using IntelliSense. So I'll click enter, and then in parentheses we're going to type in the variable that we want to display. So this is gallons used, and I'll go ahead and close that and add our semicolon. So we can go ahead and save this. Make sure that our class is set as our startup object, and we can go ahead and run this. So what we're expecting is the system to divide 500 by 25, and we should see that output in our info log in the user interface. So we can see here that it did the math, and we have 20 displayed in the info log. In this lesson, we will review the key operators in X++ code. First of all, we have the equals operator. This assigns the expression on the right of the equal sign to the variable on the left. We also have our plus equals sign. This assigns the variable on the left the current variable value plus the expression on the right. This would be the same as variable equals variable plus a new expression. We also have a plus plus. This increments the variable by 1. This operator is only used with integers or reals. We also have a minus equals as well. This assigns the variable on the left the current variable value minus the expression on the right. And then of course we have our minus minus, which decrements the variable by 1. Let's take a look at some relational operators. First we have like, which returns true if expression 1 and expression 2 are like. We also have the bang symbol, which is a not. We also have a bang equals, which is an inequality operator of not equal to. We also have the ampersands, which is logical and. We also have logical or. And then additionally, we have all of our inequality operators. So we have our less than or equal. We also have returns true if both expressions are equal. Then we also have our greater than as well as greater than or equal to. Macros can still be created in Dynamics 365 for finance and operations to store a value that will not be modified. They are created in either a macro file or by using the pound define keyword. So we can see that here with our either hashtag or pound define. However, there is a new modifier to create constant variables. By placing the keyword const before a variable, it will create the value that cannot be modified. Let's now take a look at some arithmetic operations. So the first one we have is known as a left shift, and as you can see, it is noted by the 2 less than signs in successive order. So the left shift is simply a multiplication by 2 on expression 1. So if we had something like 1 followed by my left shift operator and then a 4, it means to perform 4 left shifts on the value of 1, which is 4 multiplications of 2. So 1 times 2 times 2 times 2 times 2, which would have a value of 16. A right shift is a similar concept, except for it uses a division by 2, and it is represented by two successive greater than symbols, which we can see here. We then have the asterisk, which implies multiplication. So if we had a 4 asterisk and then 5, the output would be 20. The forward slash also would represent division. So if we had 20 forward slash 5, the output would be 4. We then have the div operator, which is used for integer division. So it only returns whole numbers based on two expressions. So for example, if I had 100 div 21, it would return a 4 since 21 only goes into 100 4 times. It would have a remainder of 16. However, that value is not returned using the div operator. Now, if we used the mod operator instead with the same expression of 100 mod 21, it would return the value of 16. That's the remainder from the division of 121. The tilde is a unary operator, and it performs a binary not operation. So this means if we had tilde 1, it would give us an output of -2 since it's using binary. Then we next have the ampersand, which this is also binary and. So that performs a binary and operation on two expressions. Likewise, we then have the caret, which is binary XOR operation, and the single bar will represent the binary OR operation that performs a binary OR between the two expressions. And then the single bar is usually located under the backspace key on most keyboards. We also have the plus and minus symbols, which represent themselves, where the plus symbol adds expression 1 to expression 2, and the minus will subtract expression 2 from 1. And then lastly, we have the question mark down here at the bottom, which is known as a ternary number. It takes three expressions, so we can have something like expression 1, question mark, expression 2, colon, expression 3. That means expression 1 is true, and it will return expression 2. So here we have, the question mark, expression 2, colon, expression 3. So if expression 1 is true, expression 2 is returned. Otherwise, expression 3 will be returned. So this slide represents a ternary example. So here we have our question mark operator, and so we have I equals, and then we have a 4,000 is greater than 4. So 1 will be returned, else 5 is returned. So as 400 is greater than 4, 1 will be returned. So I would then equal 1. Now let's take a look at the order of operator precedence. So this is very important when determining how things will be executed in your code and ultimately helping you achieve the output you want. So the order is indicated by this table, with the first one being the unary operators. Those are things like negation. The second order is the multiplication, the left and the right shifts, and the bitwise and binary and. We also have the bitwise exclusive OR. The third order of operation is additive, which is subtraction and addition, or the bitwise binary inclusive, or which is represented by the single bar here, as we can see here. The fourth thing to be executed is the relational or equality operators. And those things are like greater than, less than, equal to, like, or the not equal to symbol, which we see over here on the right-hand side. The fifth is our logical operators, or our and or. The double ampersand representing the and the double bar representing the or. And lastly is our conditional. This is the true unary operator of the question mark and the colon that is associated with those expressions. In this lesson, we will review the basic syntax for X++. In Visual Studio, the methods start with one tab. Everything within the method will start at 2 tabs. The starting parentheses on method declarations and calls should be the character just after the method name with no space. And lastly, if there are one or two parameters, the parameters can be listed on the same line. If there are more than two parameters, you'll move each parameter into a new line and indent by 4 spaces. It's also important to only have one statement per line. You'll break up complex expressions that are more than one line to make it more visually clear. You'll use a single blank line to separate entities, and you should not use parentheses around the case constraints. Constants. You do not use parentheses around where expressions and one space between if, switch, for, while, and expressions starting with parentheses. You should use braces around all code blocks except for around case clauses in a switch statement, and use braces even if there is only one statement in the block. Let's now take a look at some basic output. So first, we have create a box. So to create a box with X++ code, you would use box followed by 2 colons, and then you can have the type of box. So for instance, you might have info, you might have warning, you might have error. So then you would specify the type, and then you can also specify either yes or no. And you can also create a dialog button for these as well. So here we can see a code snippet for the box output, which will create a pop-up box displaying text to the user. So here we can see we just have our demo class, and then we have our runnable class here on line 7, followed by our curly brackets. And then we have an info box. So we have our box followed by the 2 colons, and then we have the info, which it's going to display. So here we want body text, we want title, and then to have the help text. And you'll notice that each one of these is separated by a comma. And then of course we close that in parentheses and follow that up with our semicolon. And then down below we can see our warning box. So we can see here that it's going to say the body text, which would be this posting needs receiving first, the warning title, and then the help text. Let's see what this would actually look like in the user interface. So this is what that code is going to look like within the user interface. So we can see this posting needs receiving first, and then we can also see the info log that displays with just body text here. So here's the output syntax for an info log. So here we're just displaying an info log, and we have the 3 different types. We have the info, warning, and error. We can see down below here that the info log will display in a blue bar in the user interface. We'll have the warning in yellow, and of course the error, which is in the red in the user interface. So here we just have our basic info, and then in parentheses with quotes around it, information notice to the interface. And then our warning will have the warning, and then our string, and then error followed by our string. And then of course you'll have your semicolon at the end of each one of these lines. So by using set prefix, you can create an info message with a message details link. The link will show the info statements created after the call to the set prefix. You'll need to include more than one info statement for the message details to appear. So here you can see basically how we did this is we have our runnable class. We would then use the set prefix, and then we have, for instance, results, and then we would have the message lines. So the info log lines, I should say, we have set are the detailed message and details. And then we've set the prefix as this results page here to show message details in the user interface. Here we can see output syntax for a dialog. So again, we have our runnable class, and then we now have our dialog button that we are going to declare up here, then followed by the semicolon. And then here we have our dialog button equals, and we're going to set that to a box followed by the colon. And then this is a yes, no, cancel, and then you can see each one of those yes, no, cancel here in the user interface. And we're asking, do you want to continue? So we have this yes, inquire, and then help text as well. In this lesson, we will take a look at additional basic syntax, including supported statements and loops, if-else and switch statements, and while and for statements. In programming languages such as X++, you can specify conditions under which a block of code must be executed or skipped. Each conditional test evaluates the either true or false. So first we have if and if else statements. So the if statement evaluates a question and executes a statement or set of statements if the condition is true. You can provide an alternative statement or set of statements that are executed if the condition is false, which is the else statement. We also have a switch statement. So the switch statement is a multi-branch language construct. You can create more than 2 branches by using the switch statement. This is in contrast to the if statement. You have to nest statements to create the same effect. We also have the while loop. So we have a few here, and their loops are repetitive constructs. So X++ has 3 different types, and the first one is the while. So this enables you to repeatedly execute one or more statements as long as a condition is true. So the statement will be executed from 0 to many times, depending on how many times the condition is met. We also have do while. So a do while loop is similar to the while loop, only now it is always executed at least once. And then lastly, we have our for. This is similar to the while loop, only there is an initial value to a control variable, and you can increment or decrement that value. So let's take a further look at each of these. If statements comprise of a single if statement, 0 or more else if statements, and 0 or 1 else statement. If none of the conditions are true for the if and else if statements, the else statement will be the result. Curly braces are required to encapsulate all the logic performed when a condition is true. Switch statements will go into the logic when the expression in the switch statement matches a case value. If no case statements match, the default statement will be used. It's important to note that a default is not required, but is a best practice to include. Break statements are needed, otherwise the logic will continue to flow to the logic contained within the immediate below case statement. Break is used to exit the logic. So here we have some examples here, and here we have our demo class, and then we have our if statement here. So we say here, if oil change is greater than or equal to 2, the info log will display that this is a repeat customer. If this is not true, so if the oil change is less than 1, which is displayed here, we're going to say we're going to delete that customer. It's deleted customer. And then we have an else. So we have an else for if neither of these are true, we'll display new customer. On the right, we have a switch statement. So here we're initializing, we have our oil change we're setting is equal to 3, and then we have this string set to answer. So down below we have our switch statement, and below our switch, our oil change switch, we have our curly braces here. And so we have case 1 and case 2. So if case 1 is true, we're going to have this is a first time customer, and this will break and stop. If we have case 2, it will be a repeat customer, and this will break and stop, or we have a default, which will display as a frequent customer. And then we can see down below our info that is going to display in string format and give us the answer. So let's now take a look at while and for loops. So there's the 2 main loops in Dynamics 365 for finance and operations, which are these both that are demonstrated on this screen. So let's first talk about this while loop here. So here we have our main method, and then we have our integer that we are declaring. So counter 1, and we are setting this equal to 0. Then down below is where we begin our while loop. So here we're saying counter 1 is not equal to 4. So while counter 1 is not equal to 4, we are going to execute the code within these braces. So what we're going to do down below here is display an info log, which converts our integer into string format in the user interface. And then we have our counter 1 that we want to display. And what we're going to do is we're going to increment our counter 1 value of 1 every time that this while statement executes. So it will start with 0, and then we'll go to 1, 2, 3, and then once this counter 1 it hits 4 or is equal to 4, it's going to stop running this while loop. So we also have the for loop over here on the right hand side, which is pretty similar to the while example. So this consists of 3 main parts for its execution. So we have our for loop that we're beginning here, and then we have our integer, which is counter 2, which is equal to 0, which is our first part. We then have our second part where we're saying counter 2 is not equal to 4. That's again very similar to our while example. And then we're setting counter 2 and we're going to increment by 1 each time that this runs. So we have that denoted by our operator of the 2 plus signs. So what we're saying is as long as counter 2 is not equal to 4, we are going to run this line of code or execute. So, and we're going to display this in an info log. So we are going to display this in an info log, and we're going to display this in string format, and we're going to say counter 2 is, and it's going to show the value. Now the value is going to be replaced where this %1 is. And what we're doing in our X++ code is we are setting the value of this %1 with this counter 2, which is followed by a comma. So whatever we put after this comma, which is counter 2, the value for counter 2 will be displayed where this %1 is. So this is going to execute until counter 2 does not equal 4. In this demonstration, I'm going to show you within Visual Studio the if else and switch statements that we have just viewed, but we're going to take a look at that within the developer environment. So first thing that we're going to do is we are going to use an if else statement. And so I'm just continuing to use my DB Hello World class, and I'm just going to change our code in between these brackets here. So the first thing that we want to do is we want to set our variable, and what we're going to go ahead and do is use our same oil change scenario. So in between my brackets, my first line of code is we are going to use our integer, and I'll go ahead and press enter, and we are going to set that as oil change, and we're going to set that equal to 3 followed by our semicolon. And then what we'll go ahead and do is start our if statement. I'm going to enter and put a line in between these two, and I'm going to start my if statement. So I'm going to say if, and then we want to say our variable of oil change is, and we're going to say if it is less than 2 or equal to 2, we should say, we are going to use our display an info log that will say repeat customer. So what we'll go ahead and do for this is in between brackets, we want, or in between our curly braces, so we're going to have an open and a close. And we're going to put in our info log here for if oil change is either greater than or equal to 2, we're going to say that they are a repeat customer. So we want to display an info log, and we'll go ahead in parentheses in between quotes, say that this is a repeat customer. We'll go ahead and close that parentheses and add our semicolon. And so basically what we're saying, if their oil change is either greater than or equal to 2, we're going to display that they're a repeat customer. And then we can go ahead and put in our else statement. So I'm going to do else, and then down below in our curly brackets, or braces, I should say, we can go ahead and put in our else. So we'll say info, and then in parentheses, and then in quotes in between those two, we're going to say that they are a new customer. All right, so we'll go ahead and save this, and we should get a issue here because we have an issue with our braces here. We have one too many. Go ahead and save that again and compile. And we can see here we have some more issues. So I'm going to go ahead and get rid of this. And we also actually are missing our semicolon. What's really nice about IntelliSense as well is you can see your corresponding opening and closing braces. If you click on one, you can see the corresponding brace here. So if I click on this bottom one here, I can see the corresponding brace that goes along with that. And so here we can see everything that corresponds, which is really nice with our IntelliSense. So I made sure to add all of my corresponding braces here so we can see that we have all of our opening and closing braces. And what I can do is go ahead and run this and make sure this is set up as my startup object. Now, basically what we're expecting here is we should have a repeat customer shown since our variable is set to 3, and we're saying if the oil change is greater than or equal to 2, they're going to be a repeat customer, which it is greater than 2. Now, if it was not greater than or equal to 2, we'll see new customers. So I can go ahead and run this now. And we can see repeat customer. Now, if we want to see, the flip side of this or the contrary to this, we can go ahead and go in here and say, okay, oil change is now going to be equal to 1. We can go ahead and run this. Now, note when I run this, it's also going to perform a build. And now we have new customer since this is less than what we specified. I'll go ahead and leave and stop running this. I will show you a switch statement. So we're going to use the code that we previously went over, but we're going to see it working and we're going to run it. So what I'm going to go ahead and do is we are going to use a switch statement. We're going to set up cases for this. So I'm going to go ahead and get rid of all of my code in between these brackets here, and we're going to go ahead and start entering some new code. So I'll just keep my class the same. And so what we're going to do is we're going to go ahead and initialize our variable here. So we're going to initialize our integer, and this is also going to be oil change, and we're going to set this equal to 3. All right, so our oil change integer is now equal to 3, and we are also going to set our string of answer. And you'll notice that I'm setting these variables on the same line. All right, so now what we'll go ahead and do is I can start my switch statement here. So I'm going to add another line in between these two, and I'm going to add switch, and we are going to use our oil change variable. I'll click enter and close that in parentheses. And so now I'll go ahead and within brackets, I'm going to basically put in all of our cases. So first here, I'm going to put in our first case of case 1. And you'll notice that all of my indents are being added for me automatically with IntelliSense. And what we're going to say is answer, if the answer, and we're going to say first time customer. So this is what we want to show, and we'll go ahead and end that with our semicolon, and then we'll go ahead and break this case. We'll go ahead and add our second case, so we'll say case 2, and add a colon after this case, and we'll say answer equals repeat customer. And we'll add our semicolon, and we can break as well. And then I'm going to go ahead and add a default. So here's our default followed by a colon, and we'll go ahead and put in our answer equals, and we're going to say a frequent customer. and we can break from this case. All right, and then we'll make sure that we close that out with our braces, and then we can go ahead and set our info log as well. So what we can say is we want to display the answer. And I'll just go ahead and put that under here. So basically what we're going to say is we want to display, and I'm just going to go ahead and go back here. So we'll have our info log, and I want that to show our answer. So we're going to say info, and we want to do this in string format. And we want to display the answer. And we can go ahead and close the parentheses and add a colon. And then of course I'll need to add my closing brace here. So I'll go ahead and save this and make sure it compiles. And here we have an issue where answer is not declared. So we can go ahead and scroll up and you'll notice I have a typo. So I'll go ahead and fix that and do another save. And here I can see I'm just missing a semicolon, and we'll go ahead and save, and now we shouldn't have any errors. So basically what we're expecting here is we set our variable equal to 3. So basically what we're going to expect is that frequent customer is going to display, since our variable is not equal to 1 or 2. Now, if it was equal to 1, it would display first time customer. If it was equal to 2, it would display repeat. Now, since it doesn't equal either of those, it's going to display the default case, which is frequent customer. So let's just go ahead and run this. I'll click start. And we'll see our class runner. Which displays frequent customer. In this statement, I'm going to show you the while loop. So what we're going to go ahead and do is continue using our class, and I just have my main method here. And we're just going to go ahead and create a new while loop here. So I'm going to go ahead and declare my integer variable. So I'll just go ahead and type in int, and we're going to call this counter 1, and we are going to set this equal to 0. And then we'll go ahead and begin our while loop. So I'm going to go ahead and type in while, and then we're going to, in parentheses, set counter 1, and here it is. So I'll click the down arrow and click enter. And we're going to say while counter 1 is not equal to 4, so we'll use our exclamation point or bang symbol, is not equal to 4, and I'll go ahead and close this. And then within braces down below our while, we are going to add our conditions basically. So we'll go down here and we're going to have this add an increment by 1, and then it's basically going to stop once this is equal to 4. So we're going to display an info log. So I'll type in info, and then in parentheses we are going to do our int to string. Since our variable is an integer, we want to display in string, and we are going to specify our counter 1. And we'll go ahead and close that and add our semicolon. And then we want to increment our counter 1 by 1 each time this is executed. So we are going to say counter 1, and then we want to add 1 to this each time. So we'll note that by our plus plus and add our semicolon. And so basically what we're expecting is this is going to execute and add 1 to the value of 0 until it is not equal to 4. So we'll go ahead and do a save and compile. And we'll go ahead and run this. And we can see here that this has ran until it is not equal to 4. When it then is equal to 4, it then stops executing. So we can see it took the variable of 0, added 1, it was still not equal to 4, so it continued running, and then we had 2, and then we added 1 to 2 and had 3, and then that next loop would have equaled to 4, so then we stop executing. In this demonstration, I'm going to demonstrate the for loop that we can use in X++ programming. So for this one, we're just going to go ahead and continue using this same class, and we are going to begin with our for loop. So I'm going to go ahead and just paste this snippet of code into our class. In between the braces here. And I'll just go ahead and do a save. So here we can see we have our for loop, and we're initializing our counter 2 equal to 0, and then we have counter 2 is not equal to 4, and then we are going to add 1 to counter 2, denoted by the 2 plus signs. So then down below in our code, in between the braces, we have our info log that will display in string format that counter 2 is, and then basically it's going to display whatever the value is for that. And we note that by this %1, this %1 will be replaced by whatever the value of counter 2 is. And I'm just going to go ahead and tab this in so it looks a little bit nicer here. And I'm going to do the same with this line as well. So here we're expecting our counter 2 to say counter 2 is, and then whatever that counter 2 is equal to. So we'll go ahead and run this. And as you can see here, this is going to run multiple times as long as it does not equal 4. So we can see here, counter 2 is 1, counter 2 is 2, counter 2 is 3, and then once it is equal to 4, it will stop executing.